My name is Shirisha. I am from the CSM branch. Now I am describing about the voltage control crystal oscillators. In this presentation, we will delve into the world of voltage controlled crystal oscillator and their precision. We will explore their application advantages and potential of innovation in various industries. It has a two criteria in the voltage conductor oscillators. They have generators, a periodic output needs self-sustaining oscillation mechanism. Understanding voltage control oscillator. VCXOs are electronic devices that uses a voltage input control the frequency of crystal oscillator. This precise control enables them to compensative of frequency drift and achieve high stability in the oscillators. Important matrices: frequency, power, tunability, range and linearity, jitter, figure of merit. Three types of oscillators: LC tank, ring oscillator, crystal oscillator. These are three types of oscillators and they have important issues, inductor, varactors, and the meaning of inductance modeling and modeling of losses topology, varactors topology, process variation, temperature. Now VCXOS plays a crucial role in telecommunication by providing stable clock signals for data transmission and reception. Their precise frequency control ensures reliable communication in wireless network and satellite systems. A low complexity, low phase noise, low voltage phase aligned ring oscillators in 90 nm digital. Oscillator ring oscillators. Problem: inductors are hard to design. Jitter added over time in ring oscillator. Reset to reduce jitter, noise, power, etc. Very simplified circuit. Advantages in electronic testing. In the field of electronic testing, VCXOs are used to the generating stable clock signals for texting and measurement equipment. Their high precision and low phase noise contribute the accurate and repeatable test results. A low power process and temperature compensated ring oscillator with addition basic current source. PVT variation, changing from single transistor to current source for the PVT. Low voltage, low power and low phase noises. Crystal 80 mHz 50.0 mHz. The H-scope industry benefits from the VCHOs in navigation system. Avionics, their ability to provide stability, timing, reference contributes to safety and reliability of aircraft navigation and communication system. And crystal structure and materials, basic harmonic oscillators, structures, frequency responses of oscillators, equivalent. A crystal oscillator is an electronic oscillator circuit that uses two mechanical resonance of vibrating crystal of piezoelectric electric material to create an electrical signal with a very precious frequency. This frequency is commonly used to keep track of time as it works to provide a stable clockwise signal for digital integrated circuit and to stabilize frequency. For radio transmitters and receivers, the most common type of piezoelectrical resonator used is a quartz crystal. So So oscillator circuits incorporating them became known as crystal oscillator. But other piezoelectric materials include polycrystalline ceramics and used in similar circuits. Quartz crystal sonorator, quartz crystal oscillator. Operation. A crystal is a solid in which consists of atoms, molecules, or ions are packed in a continuant atom molecules or ions are packed in a regular order, repeating patterns, extending in all three spatial dimensions. Almost any object made of an elastic material would be used in a crystal with approximate transducers in all objects have natural resonant frequency of vibration. For example, steel is very elastic and has a high speed of sound. It has often used in mechanical filter before quartz. Before quartz, the resonant frequency depends on size, shape, elasticity, and speed of sound in the material. High frequency crystals are typically cut in the shape of simple regular rectangular plate. Low frequency crystals, such as those used in digital watches, and typically cut in the shape of a turning fork. For applications not needing very precise timing, a low cost ceramic resonator is often used in place of a quartz crystal. When a crystal of quartz is properly cut and mounted, it can be made to destruct in a electric field by applying a voltage to an electrode near or on crystal. This property is known as electrostatic or inference piezoelectric electricity. When field is removed, the quartz will generate an electric field as it returns its previous shape and thus can generate a voltage. The result is that quartz crystals behaves like a circuit composed an inductor, capacitor, and resistor with a precise resonant frequency. These all circuits are designed for a non-critical adjustment and operations. Crystal structure and materials. The most common materials for oscillating crystals is quartz. At the beginning of the technology, natural quartz crystals were used. Now, synthetic crystalline quartz, grown by hydrothermal synthesis, is predominant due to high purity, lower cost, and more convenient handling. One of the few remaining uses of natural crystals is for pressure transducers in deep wells. During World War II and for some time afterwards, natural quartz was considered a strategy materials by the US. Two types of quartz crystals exist, left hand and right hand, differing in the optical rotational but identical in other physical properties. Both left and right handed crystals can be used for the oscillators if the cut angle is correct. In manufacturing, right-handed quartz is generally used. The S-type of tetrahedrons form parallel helix. The direction of twist of the helix determines the left or right-handed orientation. The helix are aligned along the z-axis and measuring sharing atoms. The mass of the helix forms a mesh of small and large channels parallel to the z-axis. The large ones are large enough to allow some mobility, smaller ions and molecules through the crystals. Quartz exists in the several phases at 573 degrees Celsius, at 1 atmosphere temperatures and higher pressure. At alpha quartz underscores quartz inversion transforms visibly to beta quartz. The reverse process, however, it is not entirely homogeneous and crystal twinning occurs. Care has been taken during manufacture and processing to avoid the phase transformation. Other phase, example, the higher education temperature phases tridymite and cristobalite are not significant for the oscillators. All quartz oscillators crystals are the Alpha quartz type. Cluster of natural quartz crystal. It's like shortcut in LFT. Turning for crystal. Turning for crystal. It is a right, and the cluster of natural quartz is left. Now, coming to conclusion, voltage control crystal oscillator offer unparalleled precision and stability frequency control, making them indisable in your various industries. Their potential for innovation advancement continues to divine search and development in the field of precision timing. Thank you.